Okay, so today we're going to learn the last way of solving systems of equations, and that's by elimination. And just like the name sounds, we are going to be eliminating a variable. So what is this? This is a method for solving systems. It's a method for solving systems of equations by adding equations to eliminate a variable. Now, sometimes we're going to look at the two equations set up and we're going to see immediately that a variable will eliminate. And then other times it's not going to be as obvious. Okay? So first thing we're going to need to do is we're going to make sure that our equations are lined up. And what I mean by that is all the variables should be right on top of each other. So if there's an x in one equation, right below it should be the x in the other. Okay? You're then going to add, we're going to take off this part because we're not going to do the other part. We're going to add equations to eliminate the variable with common coefficients. It's common and opposite coefficients. Okay. Then you're going to solve the equation for the remaining variable. And then just like with substitution, you're going to substitute, once you know one of the variables, you're going to substitute it into the original equation and solve for the other variable. Okay, so first thing I want to do on number one is make sure they're lined up. So I got a y over y equals over equals x, x, constant, constant. Perfectly lined up. Now, what I want is I want coefficients that are common, that means same number, and opposite. That means one positive, one negative. Okay, well the y's have the same number, don't they? But I don't have one that is negative. So what I need to do is, as long as I multiply the same number to everything in an equation, I can multiply the whole entire equation by a number. So I can multiply this whole entire equation by -1, and that would then give us opposite numbers, right? So I'm just going to rewrite the first equation, y equals 3x plus 4. And I'm going to multiply each one of these by -1. So that's going to make that a negative y. That's going to make that a negative 1x. That's going to make that -1 times -2 is positive 2. Okay, now do I have same coefficient, just opposite signs? Yep, sure do. So now what I'm going to do is I'm just going to add these together. Y plus -y, well that completely cancels out and leaves me with 0. 3x minus 1x, that gives me 2x. 4 plus 2, that's 6. And now I'm left with just one variable, and I can solve for this variable. So I'm going to, let's move everything away from the x, so let's subtract 6 from both sides. So -6 equals 2x, and then divide both sides by 2. And so that lets me know that x equals -3, right? Okay, now all I need to do is, just like before, I can plug back into either one of the original equations. So I have y equals 3 times, now I know x is -3. Plus 4. Well, -3 times -3 is -9, and -9 plus 4 is -5. So my solution is -3, -5. So first step, make sure they're lined up. Make sure your variables, y is above y, equals above equals, x above x, and it doesn't matter the order as long as they're in the same order. Next, look and see, do you have the same coefficient, just one's positive, one's negative? If not, you may need to multiply one or both of the equations by something. And if you do need to multiply, just make sure that everything in that equation gets multiplied. Okay? So I decided, okay, yeah, they both had a coefficient of +1. I needed one of them to be negative. So I multiplied everything in the second equation by -1. So I just rewrote the first one. I multiplied everything in the second one by -1. And when I added it together, you know it worked if one of your variables eliminates. And then you can solve for the other. All right, let's try it again. All right, so here I have x plus 4y equals 13, and I have x minus y equals 3. Now I have a choice here. I can eliminate x or I can eliminate y. It does not matter which one you do. It doesn't. I just need to make sure that I multiply the whole one of the equations by something that gives me same number but opposite sign. Well, right now, both of these are 1, but one needs to be positive and one needs to be negative, right? Right now, these are opposite signs, but they're different numbers. So I can multiply the whole equation by -1 like I did up there. Would that work? Let's do that. So I'm going to rewrite the first equation, x plus 4y equals 13. And then I'm multiplying the whole second equation by -1. So -1x, -1 times -1 makes it a positive y. -1 times 3 is a -3. Okay, now notice these were in a different order than this, right? But see how they all lined up? I have x over x, y over y, constant over constant. Okay, x and -1x, that cancels out, they're gone. Okay, so that's just 0, right? Plus 4y, and that's an understood 1y, is 5y, equals 13 minus 3 is 10. Okay, well, it's just plus 0, so that's not even really there, right? So I can just solve for y, divide both sides by 5, and y equals 2. Now to get x, I just need to plug it back into either one of the first equations. So I can just do the first one. So x plus 4, but I know y is 2, so I'm plugging 2 in for y, equals 13. So since y equals 2, instead of y in that equation, I'm plugging in 2. And now I am going to solve for the other variable. Subtract 8 from both sides, and x equals 5. So my solution is 5, because x always comes first, 2. All right, let's look at this next one. Okay, again, they're lined up, and I see I've got same numbers. I got to multiply by -1 again, don't I? Okay, and again, it doesn't matter which one we do. I just I've been doing the second one. All right, so I'm going to rewrite the first equation, but I'm going to multiply the second one by -1, because what that's going to do is -1 times 3x. Now I have a -3x, and that's what I want to happen, right? I want the same number but opposite sign. But I got to make sure everything gets multiplied by that so I don't change the value of my equation. So -1 times -9y is positive 9y. -1 times 15 is -15, and now I can just add them together. 3x, -3x, cancel out. -10y, positive 9y is -1y. 14 plus -15 is -1. So then I can divide both sides by -1, and y is 1. Once you know the value of one of the variables, you just plug it back in, and you can plug it back into either one of these. I'll just plug it back in the first one again. So I have 3 times x minus 10 times y, but I know y is 1, so 10 times 1 equals 14. So 3x minus 10 equals 14, and now I just need to solve for x. Got to get rid of the constant first, so we're going to add 10 to both sides. 3x equals 24, and then we're going to divide both sides by 3. X equals 8. So 8, 1. All right, let's look at the next one. See if you can do this. Pause the video and see if you can solve this one out on your own. Okay, I need some help on the first step. So I want the same number but opposite signs, right? So I can multiply by anything. I've been multiplying by -1, haven't I? And I could multiply by -1 here if you want, because that would then make one have a positive 2 and one have a -2. So let's do that since we've been doing that so far. So I'm going to multiply the whole second equation by -1. So I'll keep the first one the same. 4x plus 2y equals 6. And I'll multiply everything in the second equation by -1. So that's positive 2x minus 2y equals -18. Okay, will that make it cancel out for me? Sure will. If I add these together, 4x and 2x is 6x. Positive 2y, -2y cancels out. We're good. 6 plus -18 is -12. And I just need to divide by 6. and x equals negative 2. Now I need to plug that in for x, and it can be plugged into either one of these. I'm just going to plug it back in the first one. So 4 times, we now know negative 2 is what x equals. So instead of x, I'll write negative 2 plus 2y equals 6. And now I just solve for the variable. So negative 8 plus 2y equals 6. Got to move the constant first when I'm trying to solve for a variable. So I'm going to add 8 to both sides. So 2y equals 14. And then if you divide both sides by 2, y equals 7. So my solution is negative 2, 7. Okay. All right. Let's try another one. Okay, now this one's a little different. Okay, let's see. It's not just going to be negative 1 that's going to help here, is it? All right, they lined up. Got x over x, y over y, equals over equals, constant over constant. Okay, I need to multiply by something that would cause the numbers to be the same number but opposite signs. And I could either get rid of x or I can get rid of y. It doesn't matter. All right, let's get rid of y. So I'm going to multiply this whole first equation by negative 2. Now the reason why I'm doing that is, remember, we want the same number but opposite signs. I already have a positive 2 here, so I need that to be a negative 2. Okay, so I multiply it out. Negative 2 times 3 is negative 6x. Negative 2 times y is negative 2y. Negative 2 times 2 is negative 4. And then I'm just going to rewrite the second one. I'm not doing anything to it. And then I'm going to add them together and make sure one of my variables cancels out. Okay, so negative 6x and 6x. Wait, we weren't canceling that, were we? But what happens? Everything here canceled out. I got 0 equals 0, which is a true statement. So guess what? Just like all the other ways of solving systems, there are 2 exceptions to what normally happens. Normally, when we solve these out, I end up with nice points, right, as my answers. But every now and then, I might either get the same line or parallel lines. Again, if it gives me a true statement, that means these were the same line. That means every point along that line is a solution, and that means there's an infinite number of solutions. Okay? All right, let's look at the next one. So we have 3x plus 4y equals 6, and we have 7x plus 8y equals 10. So x over x, y over y, equals over equals, constant over constant. Okay. 3 and 7. Well, those don't have anything in common. How about 4 and 8? Well, I could turn that 4 into an 8, couldn't I? But I actually need to turn it into a negative 8, don't I? So what do I need to multiply that 4 by to make it a negative 8 so it would cancel out nicely? I would need to multiply by negative 2. So I'm going to multiply this whole entire equation by negative 2. So 3x times negative 2 is negative 6x. 4y times negative 2 is negative 8y. 6 times negative 2 is negative 12. And I'm just going to rewrite the second equation down. 7x plus 8y equals 10. Now I've multiplied by the right number if when I add them together, one of my variables cancels out. So negative 6x plus 7x, that's a positive 1x. That's gone. Equals negative 12 plus 10 is negative 2. Is that what x equals, right? Okay. Now to find what y equals, I can plug it back into either one of the original equations. So why don't I just plug it in the first one. So 3 times x, well now I know x is negative 2, so I can plug that in for x. Plus 4y equals 6. So plus 4y equals 6. So we have negative 6 plus 4y equals 6. So we add 6 to both sides to solve for y. So 4y equals 12. Divide by 4, and y is 3. So my solution here is negative 2, 3. Okay? So when you're doing elimination, I want my equations, I need one of the coefficients in front of the variables, just one of them, to have the same number but opposite signs. Sometimes when you look at your equations, they may already have coefficients that are the same number and opposite signs. In fact, if they had started out like this, I would just go ahead and add them together because those cancel out and solve the equation. But if they start out like this where they don't quite match up, you can multiply by whatever you need to in order to make sure the coefficients are the same number but opposite signs. All right, let's try another one. So this next one we have 3x plus 3y equals 9, and 5x plus 4y equals 10. We've got x over x, y over y equals constant. Okay, this one's going to be a little more difficult. Notice, is there anything I can multiply 3 by to make 5? Nope. Anything I can multiply 3 by to make 4? Nope. So that means I need to multiply both equations by something. Let's get rid of x this time. So what's the first number that both 3 and 5 go into? That would be 15, right? Okay, what do I need to multiply 3 by to make it 15? I would need to multiply it by 5, right? So 3x times 5 would be 15x. 3y times 5 would be 15y. And 9 times 5 would be 45. Okay, so I want this to be a negative 15x then, don't I? If I made that a positive 15x, I need that to be a negative 15x. So I need to multiply by a negative 3. So 5x times negative 3 is negative 15x. 4y times negative 3 is negative 12y. And 10 times negative 3 is negative 30. Now, if we add these together, will one of the variables cancel out? Yep. Okay, so when you are looking at these, sometimes you may not have to multiply by anything. Sometimes you can just add them together and one of your variables will cancel out. If you look at it and you have two coefficients that are the same number but opposite signs right off the bat, then just go ahead and add them together, let it cancel out, and go for it. Other times, just one of the equations needs to be multiplied by something. And then you get two that cancel out because they're the same number but opposite signs. And then other times, we may have to multiply both of the equations by something in order to get coefficients that are the same number but opposite signs. So 15x plus negative 15x, gone. 15y and negative 12y, that's 3y. 45 plus negative 30, that's 15. And now if we solve for y, we got to divide both sides by 3, and y is 5. Now I can just take that and I can plug it back into either one of the first equations. So I'll just do the first one. So 3x plus 3y, well now I know y is 5, so I'm plugging 5 in place of y, equals 9. 3x plus 3 times 5 is 15, equals 9. And now we just solve for x. So I need to move the constant first. It's a positive 15, so to move it I subtract 15 from both sides. 3x equals negative 6. Then I got to divide both sides by 3, and x equals negative 2. So negative 2, 5 would be my solution. Okay. All right, what about this one? Okay, we got 2x minus 4y equals 18, and then negative 5x minus 6y equals 3. Well, which one do we want to get rid of? Well, none of them are the same coefficient, but these two at least are different signs, right? So why don't we get rid of the x's? What's the first number that both 2 and 5 go into? That would be 10, right? So I need to multiply 2 by 5, so that means the whole equation has to be multiplied by 5. And I need to multiply that negative 5 by 2. All right, go ahead, pause the video, do that, and see if you can do the whole elimination thing afterwards. Okay, so if we distribute the 5, 2x times 5 is 10x. Negative 4y times 5 is negative 20y. 18 times 5, need to grab a calculator for that one, is negative 90. Or positive 90, sorry. Okay, and then we'll multiply everything by 2. So negative 5x times 2 is negative 10x. Negative 6y times 2 is negative 12y. 3 times 2 is 6. Let's see if we can add these together. Up, cancels out. Exactly what I want to do. Negative 20y and negative 12y is going to be negative 32y. 90 plus 6 is going to be 96. And now I just need to solve for y. So divide both sides by negative 32. And we get negative 3. And then just like before, to find the other variable, let's take that first equation. 2x minus 4, but now I know y is negative 3, so I'm plugging that in, equals 18. So 2x, negative 4 times negative 3 is positive 12. And then I'm just ready to solve for the variable. Move the constant first, so subtract 12. 2x equals 6. Divide by 2, and x is 3. So 3, negative 2. All right, why don't you pause the video and try 10 on your own? So that we get the same answers, try eliminating the x. Okay, so pause the video and try 10. Okay, if we're going to do 10, that means I need the first number that both 7 and negative 2 will go into. And it'll be 14, right? Since they're already opposite signs, I can just multiply by a positive 2 and a positive 7. So I'll multiply everything in the first equation by positive 2. 7x times 2 is 14x. 5y times 2 is 10y. Negative 13 times 2 is negative 26. If I multiply everything in the second equation by 7, negative 2x times 7 is negative 14x. Negative 7y times 7 is negative 49y. 26 times 7, go grab that calculator, and that is 182. All right, if we add these two together, 14x and negative 14x, gone. Perfect. 10y and negative 49y will be a negative 39y. Negative 26 and positive 182 would be a positive 156. And then if we divide both sides by negative 39, y equals, grab that calculator, negative 4. Okay, let's plug it back into the first equation. So we have 7x plus 5y, but we know y is negative 4, so I'm plugging that in for y. So 7x plus 5y equals negative 13. So 7x, 5 times negative 4 is negative 20, equals negative 13. And now I just got to solve for x. So we're going to add 20 to both sides. So we get 7x equals 7. Divide by 7, and x is 1. So our solution is 1 and negative 4. Always make sure that you are putting your x value first. All right, let's try one more and then we'll stop. Okay, so on this last one, we're going to get rid of, what do you want to get rid of on this one? Do we get rid of y's? We haven't done y's in a while. All right, so what's the first number that 4 and 6 both go into? 12, right? So I need to multiply 4 by 3, and I need to multiply 6 by 2. But now I need to make one of them negative, don't I? Because that's going to make that a positive 12, that's going to make that a positive 12. Now it doesn't matter which one. Let's multiply the top one by negative 3. So 2x times negative 3 is negative 6x. 4y times negative 3 is negative 12y. 6 times negative 3 is negative 18. Okay, second equation. 3x times 2 is 6x. 6y times 2 is positive 12y. And 12 times 2 is 24. So see, we had to multiply by one of them by a negative because otherwise they would not have the same sign. Okay, let's see what happens here. If I add them together. Okay, wait, x is canceled out. I thought we were trying to get y's. But y's canceled out too. Okay, so I got nothing left on this side. But on this side I have negative 18 plus 24, which is 6. Is that a true statement? So guess what happens if our variables cancel out, but it gives me a not true statement? No solution. If we were to graph these, remember these would be parallel lines that never crossed. So no solution. If you want to try the last one on your own, just to practice, the solution is 7, negative 5 if you wanted to try. Otherwise, go ahead and go to the practice and start practicing these. Let me know if you have any questions.